Hi guys, this is Feynman Education, and today we're back solving this past paper for the second part. So the third question is about states of matter, and we'll have to match these change of state with this name of change in the table. So the first one, from solid to liquid, is melting process, and from solid to gas is the sublimation process. An example is the iodine solid at room temperature, and it sublimes to become iodine gas. And the third one, liquid to solid, the name of change is freezing. You could imagine like you freeze water to become an ice cube. So the next question is about this experiment where we have the ammonium solution at one end of the tube and the hydrochloric acid at the other end of the tube, and eventually they react and they form a white ring of ammonium chloride in the middle of the tube. So the first question, state the name given to the spreading out of gas particles. This process is called diffusion. Second question, and they ask, state how the diagram shows the particles of ammonia gas are traveling at higher speeds. So here we can see that the distance from ammonia solution to ammonium chloride is longer than the distance from hydrochloric acid to ammonium chloride. So the reasoning for this answer is that the ammonium chloride is closer to the hydrochloric acid, and because they travel for the same duration, the ammonium gas particles travel a longer distance for the same duration, so they travel faster. And it's also important in this question to emphasize that they travel for the same amount of time. So that's how we know that the ammonia gas particles travel longer distance, but for the same time duration. So that's why we know it travel faster. Okay, and then next question is, they give you the information that gas particles travel at high speeds, but they ask why the white ring of ammonia chloride takes several minutes to form. So for a reaction to happen, the particles need to have enough energy and the correct orientation when colliding for the reaction to happen. So one of the reasons why the product takes several minutes to form is because the gas particles, they move in random direction. So that means they could clash into the wall of the tubes instead of colliding into each other. And for example, the ammonia gas particles could collide against each other, and that wouldn't result in ammonia chloride production. So that's why it might take a while for the reaction to happen. And then for the next question, the concentrated ammonia solution and concentrated hydrochloric acid are corrosive. So the word corrosive in here means that it can destroy or eat away at other materials once they come into contact. So here the ammonia solution and hydrochloric acid solution, if they come into contact with your skin, that could destroy or eat away at your skin. So the safety precaution you should take is to wear gloves or lab coat or goggles, just any barrier to prevent the contact with these solutions. Okay, so then the fourth question, this is another experiment where we have copper powder and we have a mixture of oxygen and argon gas. So we have the copper powder react with the oxygen to produce copper oxide, and they ask why the copper powder is heated. So usually heat is provided as a catalyst to speed up a reaction. So then in this case, it could be used to speed up the oxidation of copper by giving the copper particles more energy to react. Okay, and then next question, state why argon is unreactive. So argon is a noble gas, and it is in column 8. So it is quite stable, and it has 8 electrons on the outermost shell. Because it has 8 electrons on the outer shell, it doesn't readily gain or lose electrons. So that's why it doesn't react with anything. So the next question, give the name of the black powder that forms when the oxygen reacts with copper. So here the oxygen reacts with copper and produce copper 2 oxide, which is black in color. Alright, move on to the next question. They give you a table where we have the reading number, and then we have reading on syringe A in CMQ on the right column. So reading on syringe A indicates the volume of oxygen and argon left in the experiment, and we can see a trend that it is decreasing with time. And the first question asks, state how the results show that all the oxygen has reacted. So here in the 8th, 9th, and 10th row, we can see that the volume of the gas stays the same. So we know that all the oxygen has reacted because the volume of the mixture of gas stays constant at 58 cm3 for the last 3 minutes. Okay, so the next question give you the information that volume of the gas in the glass tube and connecting tubes is 175 cm3. So this volume is at the end of the experiment. They measure this amount of gas left. So they ask you to use this value and the results table to calculate the percentage of oxygen in the mixture. So to calculate the volume of oxygen reacted, we should use the table. So we start with 78 and end with 58. That means the volume of oxygen reacted should be 78 minus 58 equals to 20 cm3. And to calculate the percentage of oxygen in the mixture, on top we have the volume of oxygen, and at the bottom we have the volume of the mixture of gas at the beginning of the experiment. So then we have 78 plus 175, and that comes out to around 7.9%. Okay, last question for question 4. Suggest one reason why the calculated percentage of oxygen in the mixture may not be accurate. So the calculated percentage of oxygen might not be accurate could be because of the volume of oxygen measured is not accurate. So the volume of gas is usually affected by temperature and pressure. So the first reason could be that the temperature fluctuated between the readings, so the volume of the oxygen might also fluctuate a little bit. And the second reason, also related to temperature, is that the apparatus was not left to cool to the room temperature, because remember at the beginning of the experiment we were heating up the copper oxide, to speed up the reaction. Question 5. Complete the table to show the relative mass and relative charge of a proton and a neutron. So the relative mass for proton is 1, neutron is also 1, relative charge of proton is +1, and neutron is 0. Okay, and then we have this question which asks to state the meaning of the term isotopes. So isotopes are atoms of the same element, and an element is usually characterized by the number of protons. So we can also write that atoms with the same number of protons. That's the first mark for this question. And the second mark is to say that the isotopes have different number of neutrons, or we can also say that different mass number, because mass number is calculated by summing the number of protons and number of neutrons. Okay, next question, they give you an isotope of magnesium. So the 26, the bigger number on top, would be the mass number, and the 12 number below would be the atomic number, which is the number of proton. And they asked you to give the number of protons, which is 12. We just talked about that. And then the number of neutrons, we can just take the mass number minus the atomic number, which is 26 minus 12, which comes out to be 14. And the number of electrons, because this atom is neutral, the number of proton equals to the number of electrons, and the number of electrons would just be 12. Okay, so next question asks you to calculate the relative atomic mass of magnesium. So here we can use the formula where we can just take 24 times 79% plus 25 times 10 plus 26 times 11%, and then everything divided by 100, which come out to 24.32. Okay, so then next question said 1 mole of magnesium has a mass of 24.32 gram, and there are 6.022 times 10 to the power 23 atoms. So then we can just put 24.32 on top and the number of atoms in 1 mole to the bottom. So that would be 4.039 times 10 to the power minus 23. And the important thing is that it's 4 significant figures. So remember to put 4 significant figures. Okay, last question. They give you a reaction, which is magnesium react with oxygen to produce magnesium oxide. So this question is a question about limiting versus excess reagent. So the mole of magnesium that they give us is 0.5 mole. And compare that to the ratio in the equation is 0.5 divided by 2, which come out to be 0.25. And for the number of moles of oxygen is 0.2 divided by 1, which is just 0.2. So here we can see that the oxygen is the limiting reagent. So we'll use the number of moles of oxygen to calculate the number of moles of magnesium oxide. So that would just 2 times 0.2, which is 0.4 mole.